6.2, number 17. If we know that the sine of theta is 3 over 5, I write down that sine is y over r. So that means that the sine is 3/5 is telling me that y is 3 and r is 5 inside of a right triangle. But I know that x squared plus y squared equals r squared. By plugging in 3 and 5, I can solve for x and get 4. And so that means that I now know that x is 4. So if x is 4 and y is 3 and r is 5, then I can just fill in all of these. Cosine is x over r. Tangent is y over x. And then if I know sine, I get cosecant for free because I remember that s goes with c. So 3/5 turns into 5/3 for cosecant because they are inverses, multiplicative inverses, or reciprocals. Cosine, if it's 4/5, turns into 5/4 for secant, again because c goes with s. And then cotangent is just 4/3 because tangent is 3/4. 19, this question should rhyme as well. Maybe you remember your Pythagorean triples, so when I tell you that y is 5 and r is 13, you remember the Pythagorean triple of 5, 12, 13. So that means that x must be 12. So from there, you should be able to get all 6 trig functions. If you didn't do it this way, again, you could have done the x squared plus y squared equals r squared. In this case, we have a triangle, we have a tree, and then we have an observer who is 200 feet away. The angle from the ground to the top of the tree is 60 degrees. We would call that an angle of elevation. So the angle of elevation is 60 degrees. So that means that I now have a right triangle. So here we are assuming that the tree goes straight up and down, but I don't think that's too big of an assumption. So then I label my diagram with adjacent and opposite, and now it tells me if I have a 60, an opposite and adjacent, how do they relate? So I think step 1 was to label. Step 1 was to label, and then step 2 was to say, how do known and unknown relate to each other? Unknown, well, just go with it. How do known and unknown relate? That's really your step 2. And so the known in this case is I know my angle theta and I know my adjacent. And how does that relate to what I want, which is the opposite? So how do I relate theta, adjacent, and opposite? Well, that tells me that it would be tangent. So the tangent of 60 degrees is its opposite over adjacent. The tangent of 60 on my trig hand is square root of 3. I fill in for opposite and adjacent. And then you simply multiply both sides by 200. And you get the height is 200 square roots of 3, that many feet. You can approximate that on a calculator if you wish. So notice, labeling our diagram and then thinking, how do my unknown and my known relate to each other was how we found this relationship of the trig function. For 58, if I have this and I want to show that it's an identity, well, I must pick one side, so I start with the left-hand side. One thing that often helps is to rewrite every trig function in terms of sine and cosine only. So tangent is sine over cosine, and cotangent is cosine over sine, and here tangent is sine over cosine. This is not the only way to do it, but it's a technique that often works, so I'll use it here. Well, then when I distribute, this hits this and gives me sine squared over cosine squared. This hits this, and notice that the cosines and the sines cancel out to give me 1. But sine squared over cosine squared, so note that sine squared over cosine squared is just equal to sine over cosine, all that stuff squared. So that is just equal to tangent of theta gets squared. And that's why I have tan squared theta plus 1 over here. But tan squared theta plus 1 is something that we have memorized. It turns out to be secant squared of theta from one of our triangle inequalities. So that's the right-hand side. So we have shown that this is equal to this, and that's what we need to show. In 71, they say that you open up an angle. So your angle opens up this way, and one point on the terminal side of your angle where you stop is the point for -3. So there's my theta that I open up, and I stop over here at 4, -3. Well, why is that interesting? Well, because it's really telling you something about that angle. It's telling you that after you stop and you have a terminal side in this fourth quadrant, once you get a point, what you do is you go to the x-axis and create your triangle. And then once I have a triangle, I can talk about sine, cosine, and all the other trigonometric functions in terms of this triangle. So it makes a nice right triangle. And I have my x and y, but how do I find r? Well, I could either use x squared plus y squared is equal to r squared, the Pythagorean theorem, or I know my Pythagorean triple of 3, 4, 5. So I know that this is going to be 5. So I can find all my 6 trigonometric functions because I know x, y, and r. Similarly, for 73, which is the last question, if I open up an angle all the way over here and it stops with a terminal side in the third quadrant such that one point on it is -2, -5, well, then this big angle theta, after I stop with this terminal side and I pick a point on it, then I walk to the x-axis and create a triangle. Once you do, you have now created a triangle, and you can have a trig conversation about that triangle. Okay? Notice here x is negative and y is negative. So to find our r, we come over here and do x squared plus y squared is equal to r squared, because I don't remember a 2, 5 something Pythagorean triple. I remember 3, 4, 5, but okay. So -2 gets squared is a +4. -5 gets squared is a +25. So you get that r is the square root of 29, and you can find your 6 trig functions. And that's it for today. Great work. Let me hit